Welcome to lecture number 16 of irrigation and drainage lecture series. So, in this lecture we will be focusing on water application methods. So, basically in the as I said, and I think the previous lectures. So, when you are talking about irrigation, so there are three things we should keep in mind. So, the one is when to give irrigation, okay. So, how much to give irrigation and how do we give irrigation, okay. So, the how do we give irrigation, that is the application methods we are targeting, and the rest and the two, like how much and when to give irrigation. So, though these things have already discussed in earlier lectures. So, in this main focus is on irrigation methods. So, the irrigation methods here, okay. So, the water application methods basically they classified into the three groups. So, the first group is here, the first group is the based on the energy and pressure required, okay. So, the energy and pressure required, for example, gravity irrigation. So, it does not really require any pressure, and other category is pressure irrigation. So, in gravity irrigation the examples are borders, basins and furrows, whereas in pressurized irrigation drip and sprinkler irrigations are the examples, in which the water is pumped to the systems and by by pressure. And then the other category of the water application methods is based on the placement of irrigation water. So, whether you are placing water on top of the surface or subsurface or overhead. So, these things make a second classification. So, for example, here in case of surface application, it is called surface irrigation. So, the border, basin and furrow and also the drip irrigations. So, now drip irrigation is coming under surface irrigation, because you are applying water on the surface, and subsurface irrigation. So, if you are applying water beneath the root zone or within the root zone system. So, that is subsurface irrigation. And overhead irrigation, for example, sprinkler or sprinkler irrigation. So, overhead, so almost at the near to the crop height. So, the water is being sprayed on top of the canopy, or hand watering for gardening purpose. If you see, the water is sprayed on on the plant surface. So, this is overhead irrigation. So, this is a second classification, and then there is a third classification. So, it is called based on the wetted area of the crop root zone by irrigation. So, the water you applied on the surface. So, what kind of pattern it is going to form in the root zone. So, the wetting patterns, based on the wetting patterns. So, the irrigations are classified as flood irrigation. So, the flood irrigation basically basin, border and furrow. So, in this case what happens? So, the water which is applying on top of the surface, for example, here the furrow, right. So, in case of furrow, it creates a spherical wetting front, right, and drip or trickle irrigation. So, that is also going to make the it is a perfect the elliptical shape. And sprinkler irrigation, since you are applying throughout the surface, just like rainfall, which falls on the surface. So, it forms a rectangular wetting front pattern. And subsurface drip or subsurface irrigations, what happens? So, the surface and subsurface drip, if you see, so the circle is formed beneath the surface, because the emitter which is pointing here. So, that is really making the wetting pattern around the root zone. So, this is based on the wetted area of the crop root zone. by irrigation. Okay. So, and then after that, so the basically if you are now we are going to talk about individual irrigation methods. So, first of all, the surface irrigation method like borders or border irrigation. So, here basically if you see, so the okay. So, here we are talking about the borders. So, the border irrigation if you see, so it has a border width, or it is called a border strip. Okay. So, there is a width and length. So, this is basically the best adapted for grain and forage crops. For example, if you have alfalfa crop or any grain crop. So, the crop is grown in the strips, the borders, this is called the borders, and this is called levees, L-E-V-E-S. So, levee, okay, this is called a levee. So, the borders are concentrated in between the levees, and this is good for uniform soils with mild slope. So, the mostly I mean this is good for uniform soils. So, in order to achieve the uniform infiltration rate, and also the infiltration distribution is uniform throughout the field, and not good for crops sensitive to wet conditions. So, because the water is stagnant in the borders, so the crops which are sensitive to water condition or sensitive to moisture condition or wet condition are not suitable for this. And the typical efficiencies could achieve in 70 to 85% in this, and major investment in that land grading and leveling. So, this is very important in this borders. So, basically if the land is not leveled properly, so the water is not going to reach the tail end, and we are going to we are not going to achieve a uniform distribution of water. And generally the border strip width, it varies from 3 to 30 meter and length 100 to 800 meters. So, such a long borders can be seen. Okay. So, and it has 0 side slope and uniform longitudinal slope or less than 1%. So, the side slopes are nearly 0%, whereas there is a mild the longitudinal slope that is less than 1%, and the strips have no cross slopes. So, here the strips does not have. So, these are called strips. Okay. So, the strips does not have any cross slopes. So, and so next is, so what are the types of these borders? So, the borders could be level borders. So, here this is called level borders. Here the slope is almost flat, and so this is the border strip where you are going to grow I mean where you are going to grow the crop inside. Okay. And levees, okay, and head ditch, and so this is the flood gate where you release water to the border strip. And then the graded border, so it has a slope. So, as I mentioned, there is a grade of less than 1%. So, you can expect that grade here, and then contour levee. So, the levee or the levees are going to follow the contour lines. Okay. So, that creates the slope, and then as usual the water has to be, this is a head gate. So, once the gate is opened, the water is going to flow into the strip. Okay. So, these are the three basic types of borders. One is the level borders where the slope is 0, and the other one is graded border where the mild slope exists, and contour levees if the strips are following contour lines, that is called contour levee borders. And then so the next is the basins. So, this is also one kind of, this is kind of surface irrigation method. So, basically in basins, so the basins are rectangular or circular, the basin, okay. So, which has all around the dikes, okay, surrounded by levees or dikes. We call these are the dikes or levees, okay, surrounded. So, this is one basin and this is second basin, third and fourth basin. So, these are called the basin. The basin size could be 1 to 15 hectares or 100 to 400 meter long, and the most commonly practiced for rice and orchard or tree crops, if you see here. So, this is a circular basin, so mostly for orchard crops, right, and this kind of rectangular, the basins would be used for growing rice crops. And then this is also to different classification, like level basin, which has almost 0 slope and leveled, and water is held until infiltrates or drained away. So, once the water is entered through this, so this initially will be closed. So, once the water is completely infiltrated down, and then this will be opened, then the water will be entered to the second basin. So, the basin to basin irrigated. So, and the next is the graded basin or contour basin. As I mentioned in border, so the graded basin will have some slope, uniform slope, and also the contour levee irrigation. So, in this, the dikes or levees are going to follow the contour lines, okay. And this is constructed with 2 levee parallel and 2 perpendicular to the field contour, just like here. So, 2 levees parallel and 2 perpendicular to the levees, and similarly if they are contours, so it goes like this, okay. And the water enters along the upper contour and the flows to the lower contour. So, this already explained. So, the next is the basins. Basically the advantages or water covers basin rapidly to ensure good uniformity. So, this is an added advantage. So, what happens? So, since it is a rectangular piece of land, so water, since it is a mild slope, so water immediately enters through the basin and covers the entire field and infiltrates down. So, and also this is best suited for lands crop where leaching is required to wash out salts in the root zone. So, since if there are salts inside the field, since the standing water on top, so the salts are going to leach down. So, and it involves the least labor for surface methods. So, in surface irrigation methods, so this method, the basin method, requires less labor, and design efficiencies could reach 70 to 85%. The limitations are the levees interfere with movement of farm equipment, because the levees or the bunds which are around the basins are going to interfere with the farm of operations. So, higher amount of water is required compared to sprinkler and drip irrigation, obviously because it is a basin, and you have to flood the whole field. So, the amount of water will be more compared to sprinkler and drip irrigation. So, a major cost of basin irrigation is that land grading and leveling. So, in case of border and basin, and of course, in furrows, so the land grading is very important, and this impedes the surface drainage. Suppose if there is not enough grading or anything, so it is going to, because you are going to flood the field, that definitely going to impede the surface drainage. And so, the next is the furrows. So, the furrows are basically partial flooding of the field, because in case of border and basin irrigation, the whole field is the whole border or basin is flooded, but in this case the particular piece of land is partially wetted by creating the the channels, okay, that is called furrows. So, here basically the irrigation is accomplished by running water in small channels or furrows. If you see, so just like here, if you have some kind of furrows, right. So, water will be entered through the furrows, these are called furrows, and so this land, this is a furrow strip. So, where the plants are going to grow in this, okay. And this is constructed with or cross with any field slope, okay, constructed with or across the field slope, and water infiltrates from the bottom and side and furrows, moving laterally and downward to wet the soil and to move soluble salts, fertilizer and herbicides carried with the water. So, like the border or basins, the whole field is wetted, right. So, it infiltrates down completely vertically down, okay, in border and basins, whereas in furrows, since it is the channel, open channel. So, water infiltrates down, okay, and also it infiltrates radially or even horizontally. So, in all directions water is going to infiltrate. So, that is the difference between border basin and furrows. So, the loam soil with mild slopes, generally the slope we expect from 0.5 to 2%, and labor required is generally higher, just like basin and border. Major initial cost is construction of furrows. So, this is critical in case of furrow irrigation. And then so the next is, so the types of furrows could be here the level furrows. So, where we expect the 0 or very mild slope, almost level furrows, and the graded furrow. So, where you expect the slope of the field, right, the furrows will have some slope, and contour furrows. Here furrows follows the contour lines if the field is slopy. So, here this will show how the contour furrows are going to made. So, this definitely follow the contour lines of the field. So, the next is sorry. So, the furrows have advantages like it has 90% we can achieve the efficiency, and they develop a relatively low cost after necessary land forming activities are accomplished. So, once everything is done, the cost or the maintenance cost will be less, and erosion is minimal because it is a concentrated in the channels, adaptable to wide range of land slopes. So, this is compared to borders and basins. So, this can be adapted to wide range of land slopes. So, the limitation here could be not suitable for highly permeable soil, where the vertical infiltration is much higher than the lateral entry. So, in these three surface irrigation methods, what we do, we basically release or deliver water at the one hand, this is called head end, and we expect this water reaches the tail end, tail end. Okay. Okay, what happens? So, suppose if the soil is highly permeable, so the infiltration rate will be more. So, the water which is delivered here is going to infiltrate down and hardly reach to the tail end. So, that is not the intention of the surface irrigation. So, so that creates the non-uniformity of water. Okay. So, that is the limitation, like field should not be highly permeable, and a higher amount of water is required compared to sprinkler and drip irrigation methods, and furrows should be closely arranged. So, that you get more uniform wetting fronts or infiltration rate. Okay, so, the next is the sprinkler irrigation, which is pressurized irrigation. So, in the first category, so if you remember, so the sprinkler irrigation in this the water is delivered through a pressurized pipe network to sprinklers, nozzles, jets which spray the water into the air to fall the soil as artificial rain. So, this particular thing will have a sprinkler. So, this device called a sprinkler. Okay. So, the water which will be pumped or pressurized water will enter through the sprinkler, and this is going to spray water on the surface, and the water is going to fall to the ground just like rainfall. Okay. It is just like a rainfall. Okay. So, this the design of the sprinkler head is really very important. Okay. And the design will vary with different flow rates, okay, or discharge rates we expect. So, and the light sandy soils are very well suited, light sandy soils are very well suited in this case, and sprinklers can be used on any topography. So, it can be used in flat lands, graded lands, even hilly areas. So, this does not require any graded in a land grade, because the water is forced or pressurized using a pump, whereas in other case like border basin furrow, the water is flowing on the surface through a gravity. So, that is the difference, and sometimes used as germinate the seed and establish ground cover like lettuce and alpha and sod. So, these crops what have initially, so this requires, while germinating, it requires water spray on top. So, the sprinklers can be used as creating artificial rain on top of these crops, and very high efficiency water application compared to surface irrigation methods. The pressurized irrigation method is more efficient because less water is required to spray on top of the surface. Then high capital investment, but has low labor requirement. So, here this is the main investment is to buy the laterals and all the sprinkler systems. So, that really involves a lot of cost as compared to the surface irrigation systems, but because the system components are well designed. So, this requires a low labor requirements, only attaching the components. So, then after that even the maintenance is very less. So, and so the next, the types here, the sprinkler irrigation types or it could be like a portable. So, the portable or hand move. So, what happens, the laterals will be moved. So, this is one lateral, it is showing here. So, the sprinkler head. So, the part of the field is going to be irrigated. So, then after that, once the irrigation is done, so this lateral is going to move to the next point and irrigate the next piece of the land. So, this is called the hand moved sprinkler system. Then the other one is solid set permanent systems. So, if you look at the lawns or even commercial crops, for example, grapes and other places. So, solid set or permanent systems are permanently installed. So, you need not move the system out. So, this is, and other one is travel gun system. So, if you see here basically it consists of a gun. So, the gun delivers the water with high pressure and irrigates the entire piece of the cropland. And the side roll system. So, the sprinkler lateral is mounted or kind of axle, it acts like an axle to a number of wheels. Okay. So, this entire thing is going to roll right like from one place to another place. Suppose if you want to irrigate this area, right. So, it goes slowly, I mean the entire system moves very slowly, so that it gets enough water for this piece of land, and so that is why this is called side roll system. So, one end to another end, so it moves very slow, and irrigate the entire land. The other kind is the center pivot and linear move system. So, in this, so what happens, it could be like a center pivot. So, the center and then so everything is going to have the wheels, okay, and all sprinklers are mounted on the on this lateral. So, the center pivot, so this is fixed and the entire thing is going to move like a circular direction, okay, circular ray. So, it is going to move. So, so if you have a rectangular piece of land, so this portion is going to be irrigated and the rest, the corners are not going to be irrigated. Okay. So, this is the one limitation with the center pivot system. Okay. So, in order to avoid this center dryness, so some systems will have a gun, right. So, that is like a travel gun here. So, that definitely will wet the corners. Okay, so the advantages here, the sprinkler system, so readily automatable. So, because the components are well designed, right, it is easily automatable and it facilitates to chemigation and fertigation. So, both fertigation and chemigation can be done by pumping the fertilizer or liquid fertilizer along with the irrigation water in the system. So, and the reduced labor requirement are needed for irrigation. So, here the labor requirement will be reduced, because once the system is installed well in the field, so the labor requirement will be very less. But whereas in surface irrigation systems, every time you have to go and check whether the water is moving or there, if there is a blockage, then you have to remove everything or remove the soil, the blockage and other things. But this system is efficient and it does not require the frequent observations. And the limitations could be many crops like citrus for example, or sensitive for foliage damage when sprinkling with saline waters. Okay, so here limitation could, since you are applying water on the top of the surface for the crop, that means foliage application. So, the sensitive water sensitive crops may not be suitable for this. For example, citrus generally is very sensitive for the moisture at the top of surface. So, initially high installation cost because of the components, then after that the maintenance after that the labor cost is less because no labor is required, and high maintenance cost because so the maintenance, basically the blockage of sprinklers or sprinkler head dysfunctioning, the malfunctioning, all those things. So, and so that is the reason. So, the maintenance cost will be more in this case. And then, so the next is the drip irrigation. So, the drip irrigation, the sprinkler irrigation, you have to create the spray on top of the surface, whereas the drip irrigation, so the water is applied to the plant nearer to the surface or nearer to the plant root by drop. Okay, drop by drop. So, here if you see, the constant steady flow of water is applied directly to the root zone in this. So, the applicators generally orifices or emitters or porous tubing or perforated pipe. So, these are the applicators. What happens? So, suppose this is the plant. So, the drip at this point. So, water is flowing, right. So, there is the pipe will have opening at one point. So, that drips water at that particular point and wets only this portion. So, there is another plant here. So, this portion will be wetted. So, the rest the portion between two plants is dry. Okay, this is wet. So, wet pockets and dry pockets you can see in the drip irrigation system, whereas sprinkler irrigation system you see the whole piece of land is wet. Okay. And this is not designed for large root systems, because since you are applying limited water on top of the top surface only required by the crop and the crop root zone. So, the deep rooted crops are not suitable for drip irrigation, and suited for situations where the water supply is limited. So, like desert areas or where the water supply is very limited. So, then drip irrigation is really promising irrigation system, and very effective applying nutrients and insecticides through drip irrigation system. Just like in sprinkler irrigation systems, this is very much effective for fertigation and other chemigation. Buying the drip irrigation induces water loss even further by preventing runoff across the surface. So, burying, so if you are, this is generally applying on top, but if you are using the same system underneath the ground, though this is called subsurface system. So, subsurface drip. So, in that even you can still apply water effectively by reducing the evaporation, right, evaporation losses and also the runoff losses. Generally there is no runoff, but mostly the evaporation losses will be avoided. So, the advantages here, the drip irrigation. So, this is highly efficient system compared to surface as well as sprinkler irrigation systems. A limited water source can be used, right amount of water can be applied to the root zone, can be automated, and reduces nutrient leaching, labor requirement, operating cost, and nearly uniform distribution of water. So, that can be achieved with the system, and lower pressure are required, low energy for pumping, because see the water has to pass through the small pore. So, like if you have a drip, so the water has to pass through the small pore, right. So, high pressure, and also we are expecting drop by drop. So, the pressure of pumping would be less compared to sprinkler irrigation. So, and high initial cost here, and technical skill, labor is required, and the closer spacing is required, and also it required high initial cost in case of closer spacing. And damage to drip tape may be occur because of rodents, and cannot wet the soil volume quickly, and facilitates shallow root zone, and needs clean water, because in both drip and sprinkler irrigation the water quality or water should be clean. So, that is the reason these two systems will have an extra filtration system. So, that water which is input to the system will be initially filtered and then pass through the system. Okay, so, and also there are other form of irrigations. So, like here you have hand watering. So, generally the nurseries and fruit trees, capillary irrigation. Okay, so, the wet the root zone by capillary rise, and localized irrigations, water is applied around each ground plants and wets the root zone only. Subsurface irrigations, it is already mentioned before. Okay, this table gives the whole comparison of all irrigation systems. So, basically, so here if you see the soil, mostly for this surface irrigation systems, loamy to heavy soils, whereas sprinkler drip subsurface, so sandy soils are mostly suitable. So, infiltration rates could be moderate to low, and this is also moderate to low, and moderate to high infiltration rates can be achieved. So, crops, closely growing crops, and widely spaced crops in this case, and generally short crops, otherwise you have to increase the riser pipe, that will add the cost, and widely spaced crops, drip irrigation in order to reduce the cost, and row crops generally subsurface irrigation, sub irrigation. Similarly, there are other parameters we can go through it, okay, and like labor requirement, capital, windy climate. So, and there are other few more. things like here energy requirement, right. So, energy requirement basin border furrow, it does not require any energy. Sprinkler drip sub irrigation does not require, whereas sprinkler drip it requires energy because you have to pump the water through filtration system and whole system. And skilled labor case, the skill required to establish basin, okay, and here no skill required for border and moderate skill, whereas high skill are required for other irrigations. And operational maintenance, so this is easy, whereas not easy, not easy, not easy. So, go through these differences very comprehensive and very useful. Okay, so this is all about the description of the irrigation systems. So, we started with the surface irrigation systems. So, it is called borders, basins and furrow irrigation systems. So, and pressurized irrigation systems like sprinkler and drip irrigation and also sub irrigation. So, all together, so see surface irrigation systems are easy to irrigate, and nearly less skill is required in case of surface irrigation systems, and no energy required because it is a gravity irrigation, and efficiency wise compared to the pressurized systems, so less efficient, whereas pressurized irrigation systems. So, since the water required for passes through the system should be clean, and you need a filtration system, or and also the cost is more and more skilled labor is required to operate. Okay, so, and then there are other differences we have seen, you can go through that, and the next class we are going to see the design. So, the hydraulic principles and how furrow irrigation is being designed, and border irrigation and basin irrigation. So, you are going to see the next few classes with an example. Okay, thank you.